Could be the camera.
Yeah, a little hard to see. I think that's the best. Alright, systems of equations. So the first thing I want to talk about is what does it mean? What is a system of equations? And let's think about some different things we've seen in algebra. What would we call that? X. What would we call it?
X.
Okay. What if it were Y? Or Z or A?
Unknown number.
An unknown. Yeah, what's another name for an unknown?
Variable.
A variable. Either of those terms is fine. An unknown or a variable, right? What if we have something like this? 2x minus 7. What do we call that altogether? Maybe actually maybe 2x squared minus 7, since we just did exponents. Is this an equation? What's missing? Why can't it be an equation? Why can't we
The
do
X. X is there. You don't.
What does equation sound like? Equation.
Oh, it has to equal.
Yeah, this has no equals. So the term for this was an expression. An expression is a couple of terms, usually, combined together. But there's no equals. There's nothing that it equals. And as long as we only have an expression, we can't actually solve for anything. Right? All we can do with expressions is try to get them as simple as possible. Now, we also looked at things like this. 2x minus 7 equals 11. And that would be called a equation. Or an equation. Now if we look at these, what do we call a number in front of a variable? What would that be called?
That means multiply.
It means to multiply 2 times x. And that's called a coefficient. I have no idea where that term comes from, but it helps to remember co usually means like with. So it's with the variable. The coefficient is with the variable. What do we call a term that doesn't have a variable? Like in this case, the 7 here, or minus 7. Does anyone remember what we call that? It's a term, it's a number, so it doesn't change. We call it the constant term. Can you solve this?
Yes.
Yeah. We would add the constant term and divide by the coefficient, right? Let me give you another equation. Can I erase this? Anyone want to take a picture before I erase? Matt, John, you guys want to take a picture?
I don't.
Our third one is.
All right. Good? Cool. What if our equation has two, what? What does this have? Has two, it has a y and an x. It has 2 variables. Can you solve an equation with 2 variables? Not really. You guys know how to graph this. We could graph it. And a graph is a series of solutions, but it depends, like, in order to solve this, I have to know what y is or what x is. So the solution to an equation with two variables like this is typically a graph. Right? We would do something like this. Any point on this line will give us a solution to that equation. Right? The first one we put was 0, 1. When x is 0, y equals 1. So what we have is 1 equals 2 times 0 plus 1. 1 equals 0 plus 1, or 1 equals 1, which is a true statement. So that is a solution in a way. Right? 0, 1 is a solution to this equation. But it's not the only solution. Right? X could be 1, and if x is 1, then y would be 3. 2 times 1 is 2, plus 1 is 3. So that's another solution, is this point here, 1 comma 3. So we have a whole bunch of solutions. There's not really like a way to solve this outright. I can't solve and say, it's definitely this. Until now. Dun, dun, dun. Okay? So today we're going to learn about something called systems of equations. And what that means, a system of equations is something that's going to allow me to solve two equations at the same time. So some people also call these simultaneous equations because we're solving two equations at the same time. For today, most of these, all of them, are going to look like this. 2x plus 4y equals so 10, and then 2, oh wait, yeah, 2x minus 4y is going to equal So if we were to look at just one of these equations, you've seen stuff like this before. 2x plus 4y equals 10. And we called that form standard form, right? So we know that this is some sort of a line, right? Maybe it's a line like that. And then we know that this one also is in standard form. It's also some sort of a line. Maybe this one is a line, I don't know, like this. So I have two lines. I have two variables. I have two equations. And I'm going to come up with one solution. The one solution to any system of equations is the point where those two lines meet. What is the point where those two lines meet? But the way that we solve it is not always going to be with a graph. Okay? The way I'm going to show you today is just pure, numbers and letters and adding and subtracting and algebra. There's no graphing at all involved. But we're still finding the point where those two lines meet. Even though it's not going to seem like it at first. Okay, so let's solve this one. This is called a 2x2 system. 2x2 system has, so we say this, 2x2 system. The reason it's called that is we have two variables and we have two equations. Two variables by two equations. Or maybe it's the other way around. Two equations and two variables. I don't know. 2x2 system. What are our two variables here? No? X and y. Yeah. They have coefficients on them, but we're not going to let that confuse us. X and y are our variables, And here's the first equation, here's the second equation. So with the elimination method, the way that we're going to look at these today, the trick to solving with the elimination method is I have to combine the two equations into one equation. So the ones that we look at today, and this will not always be true, but the ones we look at today and the ones that are on your homework are going to be already set up for you. All you're practicing actually is adding these two equations together. What? You can add two equations together? That's new, right? That's new. We've never added equations together before. We've added things to one side of the equation and to the other. We've never actually added two equations together. So here's how it works. We try to line up our like terms. X is lined up with x's, y is lined up with y's, constants lined up with constants. And we just add. 2x plus 2x is what?
4x to the second power.
No. 4x. Right? 2x plus 2x, that's this. 2x plus 2x. Remember remember 2x means x plus x. That's what 2x means. Or it means 2 times x. Those are the same thing. X plus x plus x plus x. In total, I'm adding 4x's together. So 2x plus 2x equals 4x. Really all I have to do is add the coefficient. 2 plus 2 equals 4. And the variable stays there. Now I'm going to add my y's. 4y minus or plus negative 4y. 4y plus negative 4y. What's that going to give me? What's 4? What's 4 plus negative 4? 0. 0y. 0y is just 0. So I have nothing left there. This is why this is called the elimination method. What did I just do? I eliminated y. I got rid of it. Which is exactly what we have to do. Because remember, we can't solve the equation as long as it has two variables. All we could do really is graph it. But now I only have one variable. With one variable, we know how to solve this. Now, on this side, 10 plus 14, I'm just adding two numbers. What is 10 plus 14? 24. And now I have one equation that only has one variable that I can solve. If you ever add your two equations together and you still have two variables, it could happen. But you probably just wasted your time. Okay? The whole purpose, the reason that I want to add these together is to make one of those variables disappear. Okay? In this case, I've made y disappear. All I have is 4x equaling 24. 4x equals 24. What is x going to be then? Can't I divide both sides by 4 now? Yeah, so x would be 24 divided by 4, 6. X equals 6. It sounds like a solution, doesn't it? The trick with these is, remember how many variables I had at the beginning? X and y. So now I have to figure out what y is. I'm not done when I solve for x. I need to find y as well. Yeah?
Wouldn't y just be 0?
The way that we find y is we take x and we plug it into one of these equations. Okay? So I'm going to take x and I'm going to rewrite one of these equations with x equaling 6. I'm going to choose this one because it has all positives. I don't want to deal with the negative numbers right now. Okay? So I'm going to take this equation right here. 2x plus 4y equals 10. So I just copied it down here. And now, instead of writing x, I'm going to write 6. So watch what that looks like. 2 times 6 plus 4y equals 10. Now I have one equation, one variable again. So I can solve this for y. First, I probably want to do this multiplication. 2 times 6, that's 12. So 12 plus 4y equals 10. Okay. What would you do next to solve this? 12 plus 4y equals 10. How could we get y all alone? Plus 4y equals 10. Yeah.
You can add the 12 and the 4 just there.
Can I combine these? Are these like terms? 12 and 4y?
Well, 12 and 4.
Is 4 a term in this?
No.
No, right? 4y. Those are connected. So I can't just like separate off the 4. It's a good guess though. Because you see 12 plus 4 and you go, oh, 12 plus 4. But wait. It's 12 plus 4y. What can I do though to solve this? I'm going to have to subtract something from both sides. What do I want to get rid of? What do I want to get off of this side with the y?
4.
Okay, I could try getting rid of the 4 first. But it's 4 times y. Typically, we get rid of the 12 first, right? We would get rid of this other term over here. So how would I get rid of the 12? Subtract 12 from both sides of my equation. 12 minus 12 is just 0. So if I copy this up here, I now have 4y equals 10 minus 12 is negative 2. 4y equals negative 2. How do I get y alone now?
Divide by 4.
Divide both sides by 4. Y equals negative 2 over 4. I have a smaller number up top, so this is going to be a fraction. But is there any way to reduce this fraction?
Negative 1 over 2.
Nice. This equals negative 1/2. Right? Maddie saw that we could cancel a 2 out of there and a 2 out of there. So my solution is both of these things. X equals 6 and y equals negative 1/2. Do we know an easy way of writing an x and a y together? Rather than just writing out x equals and y equals. Isn't there an easier way of writing that? If I had a point, for example, on a graph, wouldn't I write it x, comma, y? An ordered pair. So couldn't I write 6, comma, negative 1/2 to show that this is x and this is y? You guys would recognize that, right? X is first and y is second. So it turns out that with a system of equations, often you'll write your answer like this. Because we know that the first one is x and the second one is y. That's how an ordered pair works. And why does this kind of make sense to write it as an ordered pair? What did I say we were doing when we were solving a system of equations? What are we really looking for?
The point between the 2 lines up there.
Yeah, we're trying to find the point where these 2 lines meet. So if I have an ordered pair, coordinate pair, right? That kind of makes sense. That is a point where these 2 lines meet. And x is 6 and y is negative 1/2. This is kind of a simple way of writing all of that in a really short format. You guys have any questions? All right. Anyone want to take a picture? trying to remember it. You guys have to help me remember. Alright. We're going to do another one. Together. Alright? You guys are going to try to guide me through this one. So let's say I have this. X plus 5y equals 7. And then here I have 3x minus 5y equals 1. Remember what I said about these? They're always going to be set up. So what do you notice here? What is going to drop out when we add these together?
The 5y.
Yeah, the 5y and the negative 5y, those are going to eliminate. This is why we call this the elimination method. So all we're doing today is just adding these two equations together. That's your first step. It's always going to be your first step. So I make a line underneath them, because that's what we do when we add, right? X plus 3x is, this is the same as 1x, right? Yeah, so we get exactly, you guys beat me to it, 4x. And then, remember what I said? Something's always going to drop out. What drops out here? That, yeah, there's no more y's. So I just have 4x equaling, what is 7 plus 1? 8. Okay. What should I do next? Divide both sides by 4. I'm trying to solve for x, so that'll get x alone. X equals 8 divided by 4 is 2. X equals 2. Phew. Oh, I'm done, right? X equals 2. That's an answer, isn't it?
Yep. But it's not your final answer.
It's not my final answer. Why not?
I don't remember. It's, yeah.
So I know x. What's missing?
Why?
I have to figure out what y is still. How did we do that? How did we figure out what y was?
You take the top one because that one doesn't have any, has all positives, and
Sure.
you replace the x with 2.
Yeah. So I'm rewriting this equation, but now I know what x is. I know the x value where these two meet. So instead of writing x, I'm going to write 2. And I'm going to try to do that as one step now. If you don't follow this, you can ask a question, right? So I'm rewriting this equation with x equaling 2. So 2 plus 5y equals 7. Do you see what I did?
Same thing with the bottom one, right?
No, I only need to rewrite one of them. Right? So I would, if I were you, what I would do is in my notes, write a little note. Just rewrite one equation, right? Rewrite one equation with x equaling 2. Okay, now I have an equation, one variable, I can solve that. The solving process is always going to be pretty similar. What should I do to this equation to help me get y alone? Subtract 2 from both sides. Exactly. 2 minus 2 is 0, so I have 5y equals 7 minus 2 is 5. Okay, I'm
Divide
not
by 5.
quite done. Divide by 5.
Y equals 5.
Y equals 5
One.
divided by 5, which is 1. So, is that my answer? Y equals 1?
Yes. Well,
Well, it's part of it, right?
2, 1
Yeah. So here's part of my answer, and here's part of my answer. I could write it like this, 2, 1, as an ordered pair.
On our homework,
And that is my full answer, right?
on our homework, are we going to be getting these problems and then getting that and writing them on a graph? Or?
You do not have to graph these. Now, we could, right? I could take this and graph it and figure out, this, and then graph this other one, and, maybe it's like that. And I could say this point right here. What is that point right there? 2, 1. But we don't have to do that. It's important. I'm glad you brought that up because it's important to remember that this point has some significance. This is why systems of equations are important. Right? We're trying to find this point which things meet. It's like if I were trying to launch a spaceship out into space to land on the moon, I would have to develop an equation for how the moon moves, an equation for how my spaceship moves, and figure out when would they intersect. How do I make them intersect so that I can plan to land on the moon? Right. If I were analyzing a sports game in detail, right, I might lay out on the field, maybe it's a football field, I might sort of lay out a grid for myself. And I could figure out, okay, if I'm the quarterback, if I throw this ball, right, it's going to follow this path. I want it to intersect with my receiver who's running this way. Right? And so by analyzing this game, we could actually figure out exactly that point of intersection. When will the receiver catch the ball? And where? So if I'm the defending coach, I might analyze this, these videos of this other team, and I'm going to figure out, okay, he usually throws the ball this fast, and they use this pattern, and they always intersect here. I'm going to tell my defender to go right there, right, and intercept it before the receiver gets the ball. Now, there's a lot more variables in these real-life examples, but this is sort of the idea behind systems of equations. We're looking at two different things and trying to figure out where they would meet, where they would intersect. All right, let's do one more example. This example will be problem number 1 on your homework tonight. All right. So this is just kind of to make sure you get started successfully. If you write it down, if you take really good notes, you can just copy the answer down onto your homework. Oh, I forgot to ask if you guys wanted to take pictures of the last one. All right. X plus y equals 0, x minus y equals 16. Guide me through this. What's my first step? I add. What do I add?
All of it.
Yeah, I add all of it, right? But the first thing I add is the x's. So what is x plus x?
2x.
2x. If it helps you, write a 1 in front of those, right? X is the same as 1x. In your notes, you might write x equals 1x. X is the same as 1x. That helps you. All right. Y plus negative y. What happens there? 0.
Yeah.
So I'm not even going to write it. 0 plus 16.
16.
16. 2x equals 16.
Divide by 2.
Divide both sides by 2.
Then you're going to get x equals 8, right?
Equals 8.
And then you're going to have to figure out the y.
I have to figure out the y. How do I figure out the y?
You're going to replace the x on the first one with 16.
Yeah, does it matter which equation I choose?
No.
No, I can choose whichever equation I want. I like the first one because it seems a little simpler. It doesn't have any negatives, but we could use the second one if we wanted to. So I'm rewriting this. Except instead of writing x, I wrote what?
8.
8. Instead of x plus y equals 0, I wrote 8 plus y equals 0.
And then you're gonna subtract.
What if it, hold on a second. What if there had been a 2 here? What would I have written in this equation? 28? Is that what? 28 plus y equals 0? Is that what I would have written? If there were a 2 in front of my x? No.
It's 2 times 8.
2 times 8, right? If there had been a 2 there, I would have written 2 times 8. But there's not. So it's just 8. Or I could write 1 times 8. But what's 1 times 8?
8.
Just 8. Alright. At 8 plus y equals 0, what do I have to do to get y alone?
Subtract 8 from both sides.
Subtract 8 from both sides.
Y equals -8.
Y equals -8. Divide by 1. Oh wait, I don't really need to divide by 1. I already have y alone. So x equals 8, y equals -8. How could I write that answer?
In parentheses, 8 comma -8.
Boom. Boom shakalaka. Did it. You guys want to take a picture of that one?
Yeah.
I'm afraid this video is a little